Welcome to the new era of open-source intelligence. Meta's Llama 4 Scout has fundamentally disrupted the AI landscape by offering GPT-4 class vision and language performance without the massive compute requirements of the past. By leveraging a clever mixture of experts architecture, Scout provides high-tier reasoning that fits on hardware you likely already own. Today, we are diving deep into how this 109 billion parameter beast works and how you can deploy it right now. The numbers behind Scout are staggering. We're looking at a 10 million token context window, which is currently unmatched in the open-weight world. While the total parameter count is 109 billion, the sparse activation means only 17 billion parameters are active per token. This allows for incredible speeds, reaching over 460 tokens per second on professional hardware like the H100, while maintaining high-quality reasoning across massive datasets. The core of Scout's efficiency is its mixture of experts, or MOE, architecture. Instead of one massive, dense block, the model is organized across 16 specialized experts. During inference, a gating network selects only the two most relevant experts for each token. This means you get the knowledge breadth of a 100B plus model, but the VRAM requirements and speed of a much smaller 17B model, making local deployment feasible. Scout moves away from the traditional bolt-on vision approach. Most models use a separate vision encoder and project those features into the language model. Scout uses early fusion, meaning image patches and text tokens are unified from the very first layer. This deep integration allows the model to reason about spatial relationships and multi-image context with a level of reliability that previous architectures simply couldn't match. Integrating Scout into your Python applications is incredibly straightforward using the Llama SDK. You simply define the model as Llama 4 and pass your prompt along with a list of image paths. The model handles the image encoding and multimodal reasoning internally, returning a text response that describes the visual content or answers your specific questions about the architecture shown in your diagrams or photos. For production-grade deployments, VLLM is the preferred engine. It supports advanced features like tensor parallelism and native FP8 quantization. This command shows how to serve Scout with a massive 256K context window across two GPUs. By using the tensor parallel size flag, you can split the model weights across multiple cards to handle high-throughput requests or extremely long prompts without running out of memory. Getting started locally with Llama is the fastest path. Once you have Llama installed, you can pull the model and run it directly from your terminal. The CLI supports passing image paths directly to the model. You can also interact with the local server via a REST API, sending base64 encoded images in a JSON payload. This makes it easy to wrap Scout in a custom web interface or automation script. Hardware requirements for Scout vary based on your goals. For local developers, an Apple M4 Pro with 64 gigs of unified memory is the sweet spot, running the Q4 quantization smoothly. If you are a hobbyist with an RTX 3090, you can squeeze it in using ultra-low 1.78-bit quantization. However, for production use, a single H100 GPU is recommended to leverage FP8 precision and hit those high token per second numbers. Scout isn't just about vision, it's a productivity powerhouse. The 10 million token context window allows you to feed it entire codebases or hundreds of research papers at once. Because of the MOE architecture, the model maintains high reasoning quality even at these extremes. This makes it perfect for tasks like complex codebase refactoring, long-form document analysis, and sophisticated multi-turn visual dialogues that would overwhelm smaller models. The ecosystem around Llama 4 Scout has matured rapidly. With support from Llama, VLLM, and Grok, you have multiple paths to deployment. Whether you are building a local agent to help you code or a cloud-scale vision API, Scout provides the flexibility and performance needed. Its open-weight nature ensures that you maintain control over your data and your infrastructure without being locked into a single provider. Llama 4 Scout is a masterclass in AI economics. It proves that we don't need trillion-parameter dense models to achieve high-end multimodal performance. By optimizing for active parameters and unified vision processing, Meta has given developers a tool that is both incredibly powerful and surprisingly accessible. It is the new gold standard for anyone looking to run high-performance vision language tasks on their own terms. If you are ready to take your AI infrastructure to the next level, the full deployment guide and optimized quantization files are waiting for you. Head over to Effloow.com to get started with Llama 4 Scout today. Don't forget to subscribe for more deep dives into the latest AI tech. See you in the next one.